So a little bit about us, about the Fairfield Group. As one of our services, right, it's to risk training and consulting. This is what we do. Uh, the headquarters are based out of London, but well, Jameson is in the New York State. I'm in South America and Ecuador, and we have people all around. And what we do is we help our clients generate the maximum value from the software investment. That's what we try to do risk-wise. We have a global network of consultants, right, ensuring the tailored support. So if you have, for example, a need in particular in oil and gas, or if you have a particular need in, I don't know, BCPs or IT and cybersecurity, etc. We have a good network of consultants, and we have work between all of us, right, in energy, infrastructure, financial services, technology, myself, manufacturing. So that's the main idea of the Fairfield, that we're going to give you solutions, right? Our expertise, at least the ones that I can talk about, is this is what we do: strategic risk consultancy, quantitative risk analysis, right? Developing risk frameworks, decision analysis, right? Those are the ones, at least that the ones that I feel much more comfortable. And then we have a series of people that are experts in all those other fields that can help you. Some of our biggest clients are here, like, I don't know, Babco, Baker Hughes, I don't know, Bechtel, McKinsey, Merck, Microsoft, National Grid, NASA, etc. These are people that we are working with every month, hopefully. We have, as I said, in-house specialists and consultant partners as well, right? And our main idea is that we have a lot of expensive experience across the industry, right? Global reach with project delivery in more than 25 countries, and these are the four things that we think that it's our differentiator: deep industry expertise, proven track record, customized solutions, and commitment to risk-based decision making. So that's what we do, and our customers go first always. So please let us know if you have any doubt, or if you want to contact us. We'll be more than happy to engage in a conversation with you. Now, let's go to ModelRisk, right? So ModelRisk is an add-in to Excel, right? ModelRisk is an add-in to Excel that does Monte Carlo simulation, right? And Monte Carlo simulation, you will remember, where you have any model, right? Any model, any Excel model, right? That is obviously quantitative, right? An Excel model, it's quantitative, and you have different variables, variable A, B, C, etc. You can have as many as you want, right? And what happens is that with Monte Carlo simulation, each one of them is going to be potentially replaced by a distribution, right? Like this. So each variable, instead of being the same value over and over again, static, this is going to be dynamic. This is going to be, every time we're going to fetch a different value from here, and we're going to do it randomly, right? Like picking what we call samples, right, from these distributions randomly. And when these samples are generated, they're going to be included into the model. They're going to fly into the model, because this connection is not going to change, meaning that Monte Carlo simulation is not invasive. That means that the model is going to keep the logic, but at the same time, you're going to have a model that is recalculated many times, right? As the Monte Carlo simulation progresses. For example, you can have 1,000 iterations there. And what's going to happen is that you're going to end up with 1,000 different results for your model, because the model is going to be recalculated with slightly different values. Here it could be maybe 1,000, 1,500, 1,250, 1,300, etc. If this is cost, right? For each one of the variables, you will have different combinations, and this is exactly what happens, right? You will have the distributions here for the Monte Carlo simulation, and then you will have the results, and that's the main idea of the Monte Carlo simulations. With the results, you're able to do a lot of things, right? With this, you will be able to generate a histogram. The histogram is going to be able to tell you limits, right? And this is what we're going to do in our first model. We're going to squeeze the model. You will see that a model that only uses one distribution type is going to be, is going to be so powerful. So you will see the limits, you see the behavior of the variable, you can see risk appetite, and say, for example, I want to choose P80 or P90 from here, right? Or one thing that Monte Carlo simulation brings is also the capability to see the KPI, or the key drivers, right? The key drivers on which are the main variables that you have there, right? So that's what we're going to see today. Now, what else you can do with ModelRisk? Remember, dozens of distributions to choose from, more than 100. You can add uncertainty and risk events as a framework. You can set up scenarios, and we have, and I will show you the video library when we talked about scenarios, how to set up scenarios. You have correlations and copulas, and you have complete reporting capabilities, right? All of this, you have it in ModelRisk. What else you have in ModelRisk besides simulation? You have portfolio optimization using the CIPM model. You have integration with an ARIAM tool called Pelican and Project Risk's Tamara. You have time series modeling, you have data and a results viewer, you have simulation imported data managers, grid drivers reporting, etc. So it's a tool is very complete. And today we're going to see an introduction to it, right? So please feel free if you have questions to use the chat. We already tried it with Jameson, it works just fine. So if you have questions, feel free to write it in the chat. I have two screens, so I'm going to be focusing on this one. In every 2 or 3 minutes, I'm going to be looking at that just in case. Okay, thanks again for coming. Let me open my model here, and I will explain a little bit about ModelRisk first. So ModelRisk, it's an add-in to Excel, which is here. You see, this is an add-in to Excel. That means that you will have different options to set up. Remember the distributions. I'm going to go back here to this framework that I showed you before, right? This framework here. You can set up the distributions, and you can set up the outputs here, right? And that's the main idea of the model. You can set up distributions here where you have more than 100 distributions, or you can set up outputs here. This is the only thing that we're going to use today. Is this is a basic model, plus starting the simulation and looking at the results, right? It's going to be very simple. And today, as I said, every month we change the model. I plan for today to do one model I remember that I did for a pharmaceutical company years ago, and well, I didn't see my friend over there that helped me build that. But of course, this is not the same model; it's related. But I remember that we wanted to do a model to generate the cost of attrition, right? Generate an estimation of the cost of attrition, right? Attrition is how many people leave the company, for example, every month, right? And what I did, I simplified a model that I built a long time ago to do it. And I set up some rules that I'm going to explain so you understand the model, right? So first of all, you see that, well, we have the timeline here, right? Timeline goes like this. So this is time, right? The time you have 36 months, 36 months, right? That's good. So we have 3 years of potential movements, right? Every month. For each one of the months, you will start, and we have what we call a demand of staff, which is 150 people. So we're not going to grow. Our operation has been dimensioned, has been sized for 150 people. Of course, you can make this one a little bit more flexible, right? You can say, perhaps I can have 150 to 200 to 300, etc. However you like. But this one here, we set it up as 150, right? Which is this param E3, which is this little sheet of parameters, right? This one here, the 150 is the number of people, right? That's one. Then what I did is I model some static attrition, right? It's how many people leave the company, and this attrition comes in this shape, right? In this seasonal shape. So you can imagine this could be any type of business that has seasonality, retail, hotels, any hospitality, anything like that. You will have attrition that it's that's high or low, right? Or maybe it's just months of the year that perhaps the operations are very low, so the people just leave, right? So in this case, we have static attrition. We're going to improve the model, make it dynamic, but right now you see that this is static, so it doesn't move. This is the shape, and you see the seasonality there, right? And this seasonality is here. So basically, this graphic from here is the graphic for this information, right? So that means that if you have 2% attrition for 150 people, that means that 3 people left, right? That means that you will have to hire 3 people again, right? So if 3 people left and you hire people again, what we did, we generated a simulation with what we call a Bose uniform distribution, which is here, right, between 0 and 1. So this Bose uniform distribution, I will show it to you how it looks like. Right? It's a uniform distribution which looks like a rectangle, right? Because every one of the numbers has the exact same probability of happening between 0 and 1. So let me show it to you and you will see what happens there. Right? Between 0 and 1, like this, right? And then you insert to the worksheet like this, you see? You have a Bose uniform between 0 and 1. And if you press F9, you see, if you look only this number, because you see that a lot of things started to move, if you only look to this number, you have numbers between 0 and 1. It's like a dice with 1,000 or thousands of sides, right? Everyone has the same probability of happening. Now, how I used it here, because I multiplied this to this param E6, this param E6 is here, is how long it takes to fill a vacancy, right? I was going to, and I can change it, right, for a triangular. Right now, I just did just one number, 2 months. So in average, let's say that we take 2 months to rehire people. So if I press F9, take a look, for example. If I do here, I need to find 3 people. It takes me 1 month. So it takes me 1 month, that means that the 3 people are going to arrive in month number 2, right? So in this one, you see that I assume that every time that, for example, these 3 people come, I will take 1 month to hire all of them, right? There's no backlog here, meaning that you're not going to have different months for different people. That means that all of them come in month number 2, right? And the two hire, the number of hires for month number 2 is going to be 3, right? That means that in month number 1, you're going to have 0 hires, right? That means that you have a gap of 3 people, right? Because you have 100 people and 50, 3 people left. I didn't hire anyone, so that means that I have -3. And what I did, I generated an average cost of attrition, which was $2,000 a month, right? So I set it up very simply, right? Using only one distribution, which was this Bose uniform distribution here. And I did the same thing for all of them. You see, you have 150, 147, 148, like this, right? So you can see, if you like, you can even take a look like this, how these things are moving, right? And I left some graphics to be built on the fly so you can see it, right? So for example, this is, oh, let me see, I think I eliminated the wrong one. Like this is how this is moving, you see? Oops. You see, this is the number of people that you have, always with the limit of 150. You see, that at some point you have very little people. You see, you have 135 here, right? So at some point you have a lot of cost because you need people for your operation. And the main idea is to calculate this, right? This is the staff level that you have there. That's the one that I generated there, right? That's the staff level that you have there. Now, what's going to happen is that every time, you see that every month you can potentially have new hires, right? Because of this, right? You have a delay, which is totally random, and then you generate this hire. You see that with only one distribution, we created a model that could be, I mean, the salvation for a lot of companies that deal with this issue. So if you have 3 people, 2 people, etc. So what I did, I just multiplied the number of people that you have in the gap by this parameter E8, which is the average cost, the productivity cost. Let's say that for each one of them, you have to pay 2,000. This could be the cost of rehiring people. This could be the productivity cost. This could be, I wanted to make it very simple, right? So what happens, you see that every time that I press F9, this thing recalculates, the model recalculates. And what I did at the end, I did a summation of all the 36 months, which goes here in this cell K4, right? To this cell K4, I converted it into an output, which is called the total cost, right? So that means that if I run it, imagine right now I'm running it manually, right? That's why it oscillates. But what I can do, I can take a look here. You see that now I have one distribution, which is here, is the uniform. And you have one output because it's moving, you see? The moment that it moves, that means that you can make it an output. And I will start a simulation. right? And I will say, well, I want the simulation to start. It will come here. It's running the F9s that I was running for 1,000 times, and this is going to give me the cost, right? The total cost, like this, right? So now you see what happens. And now it gets interesting, right? Because right now, what I have here, let me change. Well, you see here, you have the scale in thousands, right? You have the total cost of my attrition. And you have an initial estimate of the total cost of my attrition that could be, I mean, you can see here, from minus 175 to $400,000, right? So those are the things that now you have, right? That you didn't have before because everything was static. So right now you have this. You have a mean of 300,000. So one, for example, if you want to give people, well, how much is this going to cost you? You can say, well, in average, my attrition for these 3 years is going to be $300,000. But my limit, I mean, this could be as low as 174. Remember that as this is negative, limits are in the opposite way, right? This could be from 170,000 to 400,000, right? So this is what's going to happen if you have this type of attrition, right? If you have remember, a model as simple as that with attrition. Now, what else did I do, right? Before I improve the model, right? You see that now after I run the model, you will have the distribution here, this little shape, it's called spark line, if I'm not mistaken. Yeah, spark lines, yes. So you have that. And what I did, you see that everything that moves into the model, everything that moves could be an output. Everything you see here. So the stuff that we had before, I also made it an output, right? So that means that all this graphic, the one in blue, I'm saving it. I'm storing it in a placeholder, which is called an output. So if I go here to the results and I take a look to the stuff, you see here, you see that you have two sheets with outputs. You have one that is called hires that I'm going to show you in a second, and you have this one, it's called model. So what happens is that I can go to total cost and see the total cost, or I can go here to the stuff, right? I'm going to generate a new histogram, right? And say, well, I want to see the stuff, you see, for month number 1, or for month number 4, you see? And this is the curve of the stuff between 145 and 150 people, where I can do an analysis of month number, I don't know, 12, you see, with 15, and you overlay one on top of the other if you like, right? Like this. So you have all the information there. You can do a lot of things. You can generate what we call a trend graphic like this, you see, with the model. So this is the model that you have there. The same model that you have here, but now in a graphic called the trend, right? Let me change this color, which is very dominant. So sometimes it doesn't let you see what happens, you see? So you have how many people you're going to have and how sometimes you have these valleys, right? Because you have this attrition, right? When the attrition is higher, of course, you're going to have less people, right? So you can generate these trend graphics like this, right? Why? Because you're able to set it up for all the outputs. Everything that moves is an output, can be an output, right? What I did, for example, and you will remember that what I said is that, for example, for month number, I don't know, for month number 10, you see that you have all these people coming, right? You have 17 and 11 people because of all the things that's happening in the model. So that means that what I did is I generated a graphic of hires, right? You see, month number 10, 11 people. So now you can see it from a different perspective, right? I can see it from the perspective of cost, and I can see it from the perspective of staff. Maybe this is for the people in operations, but at the same time, I can do this from the people of HR, right? How many hires I should have each month. And as I already run the simulation, you can come here to the results, take a look, and then you go to another sheet, which is the hires sheet, right? And then I go to this one, and you see that now I see the hires that you have to do every month, right? So the nice thing about this is that, of course, you will have the mean, which is the one in red, right? And this could be your guidance, but you know that perhaps this month you can have for example, a mean like P90, then P75 is going to be 14 people, you see? you can say, I want, let me see it here, right? Like this, right? This month, my plan is to hire 9 people. But if you want to be very certain about that, because you don't know, it's going to be 75. You go to the P75, or your risk appetite is very conservative. That means that that month you will have to hire 14 people. And if you want to be very, very conservative, you can budget to hire 23 people, because you have all this volatility there. Remember, because of the nature of the model. If you like, what you can do, you can generate, for example, in hires, you can generate the number of hires that you have to do as well, right? So this will be from operational people, right? Like this. So you can set up the number of people that you need to hire. For example, month number 21. So this could be between 0 and 8 people, for example, right? So that's the main idea of this model. I'm just going to make a small addition to the model, and then we're going to go to a model by project, right? So what I'm going to do, I'm going to, for example, add uncertainty to the attrition cost, right? Because right now the attrition cost is 2,000. But what if I do, and I've changed this, and I say, well, this one here is going to be a per distribution. Let's do a triangular distribution between 1,500, right? 2,000, and let's say 3,000, right? Like this. So this is the cost. The cost could be between 1,500 and 3,000 with a most likely value of 2,000. Why? Because you have different profiles, right? Maybe in the previous model, this could work if you only have, for example, more or less similar profiles and similar roles. So in this case, what's going to happen, take a look here. Now you don't have multiples of 2,000. You have totally different numbers. The number of people is still the same because I didn't change the logic, but the cost is going to be different, right? So what I can do is I can start the simulation again because I changed the parameters, right? And then I'm running the model again, right? It's going to finish anytime. And the main idea is, of course, what happens if I add variability to in this case, one input, which was in this case the cost for the cost of attrition, right? So what I have here, let's see here, I have the model, I have the total cost. Take a look here. So now you have a mean of 228,000. Before, remember that I have one between 183 and 577 now. Before it was 434, if I'm not mistaken, right? So this is started to generate this long tail, right, to the left, right? Why? Because I started to add more and more additions to it. What else I can do with this model? I'm not going to do it because I want to set up another, and I want to show you another example, which is more complete. For example, here, I can set up the attrition, right, as a distribution. So instead of this being like this, you can set up, for example, something like this, like you go to both normal, 1,0.05%, right? So you set up a factor, a variability factor to all of them, right, like this. And then you can multiply this number. I'm just going to do it for the first one, right, like this, parameter E4 times this, like that, very simple. And then you will see what happens, that this number is going to change suddenly, right? So these numbers are not going to change, but this will do, right? So the main idea of the model, of this initial model, is that, but very simply, very simply, you can build a layer on top of another layer on top of another layer. So you can add variability to the attrition. You can add variability here in the gaps as well, right? Knowing that sometimes you have unknowns, and you can ease this calculation that your demand is going to be tight and your demand is always going to be 150, right? So that's the first model that I wanted to show you. Very simple model, right? But you see that you can make it very complete, very quick, right? I have this project workforce. So let me open this model, which is a little bit bigger, and then I will answer your question. So yes, the answer is yes. You can do sensitivity analysis in the model, definitely. It says that the variable system output is that. Definitely, Mosima, if you want, Well, maybe you can write me an email and we can go on a call definitely, because I think that maybe there's something with the model that I can help you with, right? Because I see that it says that the tornado plot. One thing that the tornado plot, Mosima, is that you have always to set up the distributions. For example, a Bose per distribution like this, right? You always have to give it a name, Bose input, like for example, variable 1. If you don't add the input, your tornado chart is going to be blank. So most likely that's what's happening. But if you like, happy to engage in a conversation, and this is for all of you guys. If you have questions, feel free to write us. That's why we're here, right? So always remember to add, I'm going to write it down, the Bose input for tornado bars to appear, right? So this is example number 1, the one that I show you, very simple, and thanks for the ones that I imagine that you have, we have much more advanced people in the audience. Thank you for waiting. So this one here is a little bit more complicated, and I really enjoyed it because this one I used to use, right, in the in all the project management roles that I have had in the past, right? So let me explain to you. So what you have here, you have 10 projects. Let's imagine that you're in charge of 10 projects, right? And you have different roles. You need a reference for the roles that you will have in each project, right? For example, project number 1, you have 2 staff, let's say administrative staff, interns, 4 business people, 10 development or construction, 2 QA or quality, 2 senior PM, and 1 leader, right? Like this. These are big projects. You see that you have in total like 300 people here. So this could be even a company, okay? And now for each one of the projects, you have different phases. So you have phase 1, you have phase 2, you have phase 3, etc. So, and for each phase, for example, phase 1, what you have is that you multiply the number of people that you have here, the staff, for example, 2 people, by, you have a sheet with parameters here. Let me open it a little bit. Let me show it to you here, right? And what you have is you have the number of people that you have in each one of them. For example, for staff, you have only 50% of the reference staff that you have here, right? You have only 50%. And on top of that, you have a normal distribution, right? That you have here with a parameter for the volatility rate. That means that this is going to help you set up how many people you have, right? And this is going to help you know what is the volatility of these people, right? You see, that's why this one doesn't change, because you set up how many people you're going to have. Plus, here you have the volatility of the phase. So you know that in phase 2 and 3, you can have a high volatility. I can put a higher volatility here, for example. And of course, you can set up with any number of phases, this one. We set it up with 4 phases because that's the typical and that's small enough. Now, what you can do, you see that what happens is that for each one of them, for each phase, for each project, you will have number of people that changes like this. Why? Because you know that it's not going to be certain right now. It's going to be uncertain, right? And that's what happens. Now, on top of that, what I did, and just as a bonus, you see here that I set it up like this. And as a bonus, what I did, I generated the length of each one of the phases. Why is that? Because normally when you do project management, you want to know who, but also you want to know for how long, right? So what I did, I generated for this phase, for example, phase number 1 of project number 1, we set up a number of you see this phase length, right, like this, where we had an estimated length. As remember here that we had an estimated people, how many people should be there. Here we have an estimated length for each one of the projects, each one of the phases, right? So this is, imagine like a very simple Gantt chart that you have in your head, right? And then we added the volatility as we did before, right, with a per distribution like this. And then we multiply the phase times the volatility, right? So the volatility here is a per distribution, right? And the volatility here was a normal distribution, right? So in this case, you see that so far we have used only 2 distributions. And that was the main message of today's workforce planning models, right? That you don't need to know like a 5, 10, 20 distributions to set it up. In the previous model, we used the uniform distribution, which is the simplest of all. In this case, we're using two distributions, a normal distribution and a PERT distribution, and that is it. So the idea is that you put this layer of simulation on top of your model, and this is the one that it's being used, right? And that's the one that you will use to get your model to work. Now, what's going to happen is that for each one of them, you see, for each phase of each project, you have a different length, like this. And that's the idea, that you have everything moving. When you have everything moving, then you can gather together, and then you can gather a lot of information, right? Because here you have, imagine you have from 10 projects, phases, and the workforce planning, and the length of each one of the phases. So I set it up like 2 or 3 reports, but you will know which reports to use, definitely, right? First of all, you have this total. So don't you worry about this, because it says no simulation results. That means that I'm going to run the simulation and this is going to populate automatically. So you see here, what I have is all the samples, right? For the workforce, right? You see, this is the total workforce, not by profile. This is just how many people you need. Imagine that you're planning the layout of the office, right? And assuming that, of course, everybody will work together. Or the length of each one of the projects and each one of the phases, and how long this is going to take. For example, in this particular scenario, that means that you will have 58 people in project number 1, and it's going to take 10 months. In this one, you're going to have 96 people for project number 2, it's going to take a year and a half. But then you do F9, and you see, if you just focus on the first 2 projects, everything will be dynamic, right? That means that with only these 2 distributions that I set up, all of this is going to be dynamic. And that's the main idea, right? That you generate this uncertainty and you absorb and embrace this uncertainty into your results, so they are not static anymore, right? So what I did, you see here, I generated an output. You see, everything that moves is an output, can be an output. Not necessarily, but it can be an output. Why? Because I want to know what is going to be the number of people that I need for each project and how long it's going to take each one of them, right? So I will focus on this first, and then I will focus on this second. So what I'm going to do, I'm going to, let me see here. Let's forget about this a little bit. Yeah, I was going to hide it, but I have so many things that they are going to be messed up a little bit. So I'm going to go to the simulation. Remember, I already set the distributions. I already set the output, right? And now what I will do is I will set up and take a look to this. So of course, what you have here is still a random number. So this is not the result. The result's going to be here in the results tab. Good thing. So here you go. So what I did, I generated in the totals here. Remember, I generated here the total length, which is here. You see, the total length and the total workforce, like this, right? So what I can do is I can say, okay, so in the total workforce that I have here, now I have the view. Before, remember that we have the view by the month. Here I have the view by the project. So this is the project. And the main idea is that you can set up the outputs knowing and having any etiquette, any label, so you can see which projects are you talking about. So for example, here I can say, well, for project number 2, how many people do I need? Okay, so I need from 84 to 120 people. So with a most likely and 102. I can do it for project 5, or I can start and combine the projects. Take a look. I can do project 4, 5, 1, like this. You see, so this looks much more simple to understand, right? Than just taking one number, because now you say that, look, for project 1, it's between 50 and 70 people. But for project 2, it's from 70 to 90. And take a look to project 3, right? If you like, you can change that. You can change the view if you like. You can see it like this, right? But sometimes it works. I like it. You can see it like that. Or you can do, for example, a box plot from the same variables, right? Project 1, 4, and 5. You see, I just inserted a box plot. And if you go to the options, you can see it like this as well, right? So you can have all these different options to visualize things, right? It's amazing what you can do with ModelRisk. So once you have it, once you have that, you can see all of them if you like this. You can see your whole portfolio like this. You can see your complete portfolio and see, well, how many people am I going to need for each one of them, right? For each project. Same thing with the length. So how long is this going to take? For example, I can see it again as a, I want to change it as a histogram, right? Like this. So I can say, well, the length of project 1 is going to be between 6 and 15 months, as project 4, for example, is going to be more or less the same. Let me see another one. Project 7, project 8, you see? If you like, you can change it. So you see it's a cumulative curve like this, right? So you can see that, for example, the cumulative curves is going to show which one is going to go where, right? If you like, you can say, well, I want to see my risk appetite for P80 or P75 as we did before, right? I can say add a P80. So I know that with 80% probability, my project is going to take 11 months. That means that I have 20% probability for the project to last more than 11 months and 80% probability to last 11 months or less, which is this, you see, like that. So these types of things you can do. Now, what I did here, you see that I only did it for each one of the months. You can take all this information that I was showing there and I bring it here to my tables. For example, there you see that I have the mean for the people. How many people do I need in average, right? And how many people do I need, you see here? And how long is this going to take? Right. So what I did here I used the mean for that. Take a look here. So I use the mean for the workforce. I use it here. I use the mean. I use this function called Bosim_mean, and I also use something that's called Bosim percentile, right? For this. So it's how many people am I going to use? Am I going to need? For example, in average for phase 3, project 1, I'm going to need 21 people, but if I am very conservative, I'm going to budget for 23. Same thing here. I'm going to have 38 people for phase 3, but this could go up to 42 people, right? And if I like, I can take a look and generate what we call a cumulative curve, and that's what I was having here, where you can choose the project. For example, here, choose project 1, and you see the difference between them, right? At the beginning, they are more or less the same, 10 people, but then in phase 2, you have a difference of 1, difference of 3, and then a difference of 4 people, right? Between your mean and your P80, right? This is the risk appetite that you have. But if you choose, for example, project 5, things are going to change. You see, you have 5 people there, you have 3 people there, like this, you see? You have all these different curves that you can see in the future because you're basically predicting the future there, right? If you like to do the total workforce, which is the summation of everything, I did it like this, you see? Now you have for each one of the phases, right, a cumulative curve, right? A cumulative curve of the phase, and then you can see that how many you will need. For example, in the mean, you will need 800 people, right? And then you will have a difference with your P80, right, of 866. That means that it's going to be, the difference is going to be around 6%, right? The total number of people. Remember that at the beginning, it was a smaller number, but then when we started to add all these things, we have almost like 800 people. Plus, let me see here. Yeah, it's from the total here. Yeah. Plus, what I did, remember with the length of the project, because you have at one time who's going to do the job, and then we also had the capability of run a Gantt chart like this. So, for example, here you can set up a Gantt chart for project 4 that's going to be like this. This is the sample, right? That's why it's going to move like this, right? The Gantt chart. But what I did, for example, for this project 4, I run the simulation, and this is the mean duration of project 4, and this is the P80. So basically what you did is you calculated the difference in months. This one's going to take 9 months to finish, you see here, and this one is going to take 13 months to finish between your mean and your P80, right? If you like, for example, I can choose project number 2. Let's see if this works fine. So you run it again, right? And now, you see, This is the difference. You have 14 and 17 months. You do project number 3, same thing, right? So you can run all these scenarios. So what I did in this particular model, and this is the one that I wanted to show you today, is I added a lot of uncertainty. You see, 18 to 23 months, or however you like to do it. Well, in this case, you only have up to 20. But the main idea is that you will be able to add analysis and add uncertainty to models that are, you see, in this case, this is much more complicated than the other one. Why? Because you have 2 dimensions. You have the people and you have the length of the project, but with only 2 distributions. So please remember that we only use 2 distributions, right? This was not a distribution. We only use one distribution here, which was a normal distribution like this. And here in the estimated length, remember that we did in the volatility, we use a PER distribution. That's everything that we added to the model. 2 distributions. If the logic is as complicated as this was, right, where you have the totals, where you have all these reports, remember that the idea is that the moment that you bring uncertainty to the model, you have all these potential artifacts, these deliverables that you can get after the simulation. You can get, for example, here from the workforce. Remember, you can get it as disaggregated as by phase and project, right? You can say that by phase and project, for example, here you have, I don't know, 29 people needed for phase 3 of project 5. And if you want to be more conservative, it's going to be 32 people for the same phase 3 of project 5, because you have a different risk appetite, right? And that was the main idea of the Monte Carlo simulation process, right? For you to be able to calculate all these things. What is this going to do? It's going to improve decision making, right? Why? Because at the end, you will know what is your profile, right? What's your risk appetite? And you say, you know, I'm going to do it with 32 people here because I want the project to be well planned. So perhaps when you do the budget, you're going to budget for 32 people. How do you know if this is going to be correct or not? Remember that you have these parameters, and these parameters are going to let you, right, set up the volatility rate for stuff. So perhaps in these phases, you have less knowledge, so you can increase this to higher volatility. But in these initial phases that you know, and maybe the closeout phase is something that you already know. So you don't need to set up a very high volatility because you know and you've done it before. So this is an idea, and this is a way for you to set up your knowledge about the project, right? So this is what I wanted to show you today. I know that I have Mosima's, well, here's my email address. Today, we are not going to show the key drivers, but what you can do, for example, here, let me show it to you. You can add something like this, both input, and then you add the name, right? And you add the name for each one of them, right? Let me see. I think that we have give me 3 minutes and I will do it. So for example, this is going to be both input, the project name, and, right, the phase name and the role name like this. So this is going to be the both input for that. I'm just going to do it for the for a few of them, so you will see what happens. See there. Am I going to break everything? I think I will break everything, but at least we'll have tornado charts. Let's see. Yeah. Forgive me about breaking all these nice colors that we had before. You see that I added this both input at the end, which is basically a name for each one of them. So what I can do is I can run the model like this. And when the model is finished, right now, what I can do is I can go there and say, well, I want to see, let's see, the here in the total workforce, I can do a tornado chart, insert tornado, like this, you see? And now I know that for project number 1, right, which are the main variables. Of course, I will have to take a look because I didn't enter the each one. Well, let me see. I know, I think it will be okay. I mean, maybe for some phases, I have to do it in a little bit different way. But the main idea that what I wanted to show you, Mosima, was that by adding the both input, you have this. Of course, in this case, I did it just for showing you and for maybe for all the people in case you're interested in setting up tornado charts. I didn't have the model set up like that, so please don't think that, I mean, you can do it, but you have to think about it and take a look to it. But it's as simple as setting it up with a Bose input like I did here. If you don't want the tornado charts as I set it up before, you just eliminate the Bose input like this, and that's it. You will see what happens. I go to start in the simulation, and what's going to happen is that you are not going to have the inputs here. Take a look. You see, you're not going to have inputs anymore. So the Bose input is going to be responsible for that. Okay. Do you have any questions? Do you have any questions? I mean, I hope you enjoy the model. Please write to me in case you need it or in case you have a conversation. I'm more than happy to do it. You have that. And thank you, John, for the comment. Yeah, it's really nice. I mean, Monte Carlo simulation. It's a technique that I always consider when doing decision making, and it's a really good complement with AI and all these new techniques that you have, machine learning and so. If not, you will receive a link to the video for the model in case colleagues of yours were not able to see it. And we'll see each other next month, most likely a logistics model. Or if you have suggestions on models, please use the chat, send it to us. More than happy to build it. Right now we have this is going to be our 5th video. So thanks for your attention and for staying connected. And I'm not sure, Jameson, you have anything to add?
Oh, I just wanted to say thank you. And I thought it was very interesting that the attrition costs money and the value was 2,000 a month, because I have to say that your leaving Palisade cost that company much more a month than that. So
good. Excellent, James. And thanks for the comment.
That was a lot, really, it got me thinking about a lot of things, and that was.
Oh yeah, good. I'm happy.
Yeah.
Happy. So if you hear about Jameson or Dan, well, Dan wasn't here because I think it's a little bit late for him. He's in the UK. Now you will know who they are. So thanks. And if you want to have a one-on-one with us, and if you have some questions like Mosima did, more than happy to answer. What we want to bring is ModelRisk and Monte Carlo simulation to hopefully all of you. So thanks again and enjoy the rest of your week.